Hey everybody, welcome back. This is part C of the fashion inventory problems for module 2. And so we've got, in part C, same idea, current inventory. This is this inventory of designer objects. And for the fashion inventory part C, we're going to basically do what we did for part A. We're going to create a flat list, but we're going to find all the shoes that have black in the name. So you figure if black ever appears in the string of the name, we want to add that to our flat list. And it's going to be the same idea as a flat list. Here's a demonstration. Put that in the console and that'll output what you would expect. You figure there's going to be a new line symbol in between each of these lines and then one at the end as well. So same idea for the rest of the problems that we've been doing. They're not going to have really robust tests. What we're going to do in REPL is going to be most of what we need. Sorry, I'm saying that oddly. What I mean to say is that most of the practice you're going to get out of this is by going to Replit and messing around with the code and proving to yourself that it works using some of the assertion functions that you've done so far. Oh boy, what did we do? Let's go back, copy all of this, put it over to Replit, and through the power of laziness or preparation, depending on which way you like to look at it, I have already put an assert equal function here. You figure if the return value of this list all black shoes is going to be our flat list, which is a string, then we'll need to be able to test a string actual versus a string expected, and here's an actual copy of the expected flat list that they want. In addition to this, we're also going to create an actual flat list. Actual flat list is going to be equal to list all black shoes, the name of our function, and we're going to call that on current inventory, which is what we're going to port over in a second. Port is a really bad term for that. Well, actually, I'm not sure. It just sounds more complicated than it is. We're just going to copy and paste it. We can call that porting. So after we port over the variable current inventory, we have an assertion function now. A variable to test our function with, an expected value from our function, and then a call to our function. So the last thing that we need is an assert equal call with actual flat list, expected flat list, and should return a flat list of all shoes with black in name. Sounds reasonable. So from this point, let's kind of get rid of some vertical spacing. Creating helper functions, if needed, is going to be something that we are probably going to do for this one, but we don't need to start out with deciding whether we're going to or not. What we're going to do is just start building the pseudocode, and if it becomes obvious that we need another function or that another function could be useful, then we'll build one at that point. So the first thing that we'll need is to create a flat list string. The last thing that we're going to do is return our flat list string. From here, we want to iterate over the inventory, and keeping in mind that each step of the inventory, when we're iterating over it, is itself a designer object. So we're going to, for each designer object, we'll want to iterate over the shoes array. And then from there, you figure that what we've done here is kind of a fast-paced version of what we did in the previous problem, which is to say part A, where we created a designer object, set that equal to inventory at I, and then created a shoes. I think we called it shoes. I've called it shoes array at other places, and there's been a discussion about which one of those is necessarily correct. But the point is that we're still probably going to do that with creating the aliases, but for now we're going to assume that's something we can do after the fact. So far, we're going to create a flat list, iterate over the inventory. For each designer object, there's a shoes array, which we're going to iterate over. And then in here, we're going to check if current shoe has black in name. And if it does, we're going to assume that line 6 is in the affirmative case, because this will transfer nicely to an basically if shoe has black in it, then line 6 will be where we add to flat list, how do you say this? It's like there's a verbose way and then an easy way. Let's say add to flat list the string for current shoe. And we assume that what we mean by that is what this ends up being. Now in part A, we actually broke that into a separate function. I haven't decided if we're going to do that just yet, but for now, that's what I mean, is that we'll take the string for a current shoe and build the appropriate name of the designer, name of the shoe, price of the shoe string that is then added to our flat list. So if that's the case, probably about time for us to start writing some code. We can say variable flat list is equal to an empty string. We can return our flat list at the end. And this will be where we accumulate all of those strings. Iterate over the inventory. Again, quite simple. Variable I is equal to 0. I is going to be less than inventory.length. And to be sure, if I say quite simple and that intimidates you, it shouldn't. One of the things that you would keep in mind is that if it's not simple for you yet, maybe you should go back to Module 1 and redo problems that involve for loops until for you, writing a for loop is quite simple. Excuse me. So for each designer object, which means that at this point is where we probably want to start putting some aliases in there. Designer object is equal to inventory at I. Variable shoes is equal to designer object dot shoes. And then for each designer object, iterate over the shoes array. That's going to be, well, let's not say simple, we'll say straightforward. Shoes is an array of shoes, so we'll say length, shoes.length, j++. We're going to wrap the end of this around so our for loop lines up nicely. Check if current shoe has black in the name. Now here's where I would think that it's a great opportunity for us to create another function. So we're going to write this as though we have a function that says whether or not the shoe object contains black in its name. So we'll say if shoe is black applied to the current shoe, which reminds us we should create a current shoe alias for the shoes at j. Say shoe is black on current shoe. And we're assuming that shoe is black does something. It takes in a shoe object and it's going to return true or false based on whether or not that shoe object contains black in its name. So let's go ahead and stub out that function for shoe is black. In case you're curious, what's happening there is I'm going to hit copy, I'm doing Command C, but I accidentally hit C without hitting Command. So what usually happens is if you have highlighted it, is if you hit C, you can hit Command Z, which will back you up one. Basically one operation, or undo. So shoe is black is going to take in a shoe object, and we're calling that on current shoe. So the name of the parameter here is really immaterial. It can help if you name it something that'll assist you in understanding what it is, the same way all variable names are. But for our purposes, you don't want to consider that what we call the thing on line 23 really matters that much. It's mostly to help us understand from the context of the other function we're calling it in, what this function shoe is black is going to be called upon. So for now, let's just say check if name has black, return true if it does, otherwise return false. So we'll probably line that up into some more respectable pseudocode. And yeah, that should be okay. So that's good enough for our purposes at this point. And then we'll say add flat list to the string for the current shoe. So for this one, we are not going to create a separate function. We're just going to say flat list plus equals. And then the first thing is going to be the name of the designer. So that's going to be easy to grab from designer object dot name. We're going to add to that a comma and a space. And then we're also going to add in the current shoe and its name, add a comma and a space, plus current shoe dot price. And the final thing would be I can never hit that backslash with my pinky. I always end up hitting delete or something else. Anyway, return, sorry, we missed it. Current shoe dot price plus a new line symbol. So now this function is done. And the problem is, of course, we haven't written shoe is black yet, but if you think about it, if we assume shoe is black works, everything that we need to do is here. We create a flat list, iterate over the inventory, iterate over the shoes for the current designer, check if the shoe is black. If it is, we're going to add the name of the designer, the name of the shoe, and the price of the shoe, with the new line symbol at the end to create our flat list, and at the end we'll return our flat list. So with that in mind, the only thing necessary for us to do now is to figure out how to tell if a shoe has black in the name. Now, we could do a lot of fiddling with this, but I'm going to assume that you got most of your fiddling done in Module 1. So what we can do is, let's have a quick look at this, and I'm just going to talk this out. If we have a name that's a string, and we call index of on this string, and we look for black, if the index is a valid 0 to something, which means that it's either 0, 1, 2, 3, or all the way up to the string.length minus 1, then we know that black is contained. If we say index of on something like this, it's actually going to tell us -1, because that's the way that it identifies, hey, there actually is not an index in this string where you could find the string black. So with that in mind, we're going to use that to check if a shoe object has black in the name. So if shoe object.name, and that's the entire string, .index of black, and essentially we just need to make sure that this is not equal to -1. So we could say not equal to -1, and I am not going to wrap all of that pseudocode around there. If statements are where that becomes actually, let's say, relatively annoying, because wrapping, it's like, where does this pseudocode go? And it's like, ideally it goes above the call to else, but that can be kind of tricky to wrap the curly braces around it. So I'm just going to leave the pseudocode kind of, helter-skelter, as it were, and we'll not worry about it. So if shoeObject.name.index of black is not equal to -1, and what this means is that the index of black inside of the name of the shoe is something other than -1. It's either at the beginning of it, or it's at index 5, or whatever it is. If that's the case, then our function isShoeBlack should return true. Else, we're going to return false. Now you might have also noticed in the style guide that essentially what we're doing here is just returning this expression directly. The reason that we're not doing that right now is because I wanted to verbosely demonstrate what's going on here. But if your complaint or issue is that, hey, can I just return this directly? The answer is yes, you absolutely can. So now that we have shoe is black functioning correctly, ideally what we would do is test shoe is black to make sure that it works. Now this can take a couple of forms. We could do another assert equal call and organize it that way. Instead, what I'm going to do is first I'm going to comment out everything below here. Which is to say, I don't really want it to, actually I only need to comment out this part. 2 parts. We don't want to call to list all black shoes yet. So I'm going to comment all that out. And then up here, I'm going to grab a shoe name. And what I'm going to do is I'm going to say, I'm not going to grab a shoe name. Sorry, I messed that up. What we're going to do is we're going to grab a whole shoe object. And what we're going to do then is say console.log, and this is just a quick test just to make sure that this function is working. Shoe is black, and we're going to pass in a shoe that has black in the name. So if we run this, we should see true log to the console. Let's go ahead and test it again for one that doesn't have black in the name. And to be sure, what we are doing here is a little bit of a shortcut. So in case you're curious, it would not be a bad idea for you to organize an entire other test suite using an assert equal call to make sure that what we're doing here is accurate. So if we log this, a shoe is black called on a shoe that does not have black in the name, and then we're going to console.log whatever this expression or the statement evaluates to. And it should evaluate to false. Excellent. So at this point, we can assume safely that our shoe is black function is working. I'm going to get rid of actually all of this pseudocode because check if name has black is pretty self-explanatory. And then we're going to uncomment our actual test. So we create a flat list called on list all black shoes. That was very poorly worded. We're creating an actual flat list, which is the result of calling list all black shoes on our current inventory. There we go. Then we're saying assert equal, checking the actual versus the expected flat list, and we're going to basically doing what we've been doing the whole time. We've written a function, we have a test set up, the test is going to tell us passed if our function worked correctly, and we trust in our ability to set up the test initially to tell us that a function works or it doesn't. So I would say that this does work because we're adding to our flat list the entire time. Shoe is black is going to essentially only apply line 14 to shoes where black is in the title or in the name, which is what we want. So if we run this and we see passed, we're in great shape. We're going to copy all of this, come back over here to the input window, paste it on in there, have one quick look at the function again, and you'll probably see a copy of this or something very similar to it in the reference answers and documentation section at the end of this module. So from here, let's go ahead down, run our tests. It's correct. Excellent work. Thanks for watching this video, and we'll see you in the next one.